Consider this example. Find the slope of the function f of xy, which is a scalar function, equals y times the exponential of x plus y in the direction given by the vector u equals 2x hat plus y hat at the location xy equals 1, 1. Okay? So to find the slope of the function in some direction, the only thing we need to calculate is to find the directional derivative of f with respect to that direction, u hat. Okay? If you want to find the slope in any direction, u is given by the directional derivative with respect to u hat. Okay? So where u hat is a unit vector. The unit vector in the direction of u. So u hat is u divided by the norm of u. Okay? So we need to calculate this directional derivative. Now, this directional derivative, as you remember, can be defined as the gradient of f dot product with u hat. So that's what we need to calculate now. Okay? So we need to calculate the gradient of f and we need to calculate u hat. So let's do both things. So calculate the gradient. So the gradient of f is equal to the partial of f with respect to x and the partial of f with respect to y. We are in 2 dimensions, therefore the gradient only has 2 dimensions. So this will be equal to the gradient of this with respect. So what is the partial derivative of this with respect to x? It's going to be y to the power y times exponent to the power x plus y. And then the derivative of this with respect to y. So for this we will need to use the product rule, right? So we have to do the derivative of this times this without derivative with respect to y. So the derivative of y is 1 times the exponential without derivative plus the y without derivative times the derivative with respect to y of the exponential. So y times the exponential, which is its own derivative. Okay? So that's the gradient of f. Now we also need to calculate u hat. So u hat is equal to u divided by the norm of u. So u is equal to 2x hat plus y hat. And the norm of u is just the square root of 2 squared plus 1 squared using Pythagoras' theorem. So it's the square root of 5. So u hat is 1 divided by the square root of 5 times 2, 1. Okay? So we have all that we need. So now to calculate the directional derivative of f with respect to u hat, this is equal to the gradient of f dot u hat, which is equal to this function y times the exponential of x plus y and 1 plus y times the exponential of x plus y dot product u hat, which we have above, which is 1 over square root of 5 times 2, 1. Okay? So the answer to this is, I will use a new line. So it's 1 over square root of 5. Let's leave that at the beginning as a constant. So now we do 2 times this plus 1 times this. So clearly we can keep the exponential as a constant factor. And inside of the brackets we will have 2y plus 1 plus y, which we can turn into 3y plus 1. Okay? So that's our directional derivative. And this is at every point in space. But the question asks for the slope of the function at the location xy equals 1, 1. So the only thing that is left is to substitute the directional derivative, which instead of, so here, this is a function of x and y. So now we need to evaluate it at 1, 1. Okay, so we substitute x and y equals to 1 So we get the exponential squared times 3 times 1 plus 1, that's 4. So 4 divided by the square root of 5 times c squared. And that will be the slope of the function at that point in that given direction. Okay? I hope you understood that easily, and see you in the next video.